Welcome back. This is Mr. Hassan's Maths channel, and this is a question that I'm answering, which is actually from an Edexcel IGCSE paper, Mathematics A, the higher paper from May-June 2018. But I have used this question in one of my end of topic worksheets for my A-level class for the beginning of the A-level course, the AS course, and it's in the Algebra Basics worksheet, which is end of topic worksheet number 1, and it's question 1D from that worksheet. So I've used this question, I mean, the first week of the course for the AS is basically revision of some of the basic skills that we need from what we did in IGCSE and just to get people up to scratch. So here's a question which is a bit of a higher level question where you have to simplify this fraction which has these terms, algebraic terms. So what we can see is, if we want to simplify this, we've got to try to think of a way of maybe factorizing this, because like the algebraic expressions. So if you look very carefully, the denominator is actually a difference between two squares. And how is it a difference between two squares? Well, because we know that 2 to the power of 2 is the same as 4. All right. So we can say that 4 to the power of n is equal to 2 to the power of 2 to the power of n. And we know from our understanding of multiplying of indices that when we have a power raised, you have a number in index form, okay, which is raised to a power, you can multiply these two powers. So this would be the same as basically 2 to the power of 2n. And we could actually switch these two. We could write this as 2 to the power of n squared, because 2 to the power of n all squared will give you the same as 2 to the power of 2n, because you multiply the powers. And 2 to the power of 2 to the power of n will also give you the same thing, 2 to the power of 2n. So these two are actually the same. So I can express 4 to the power of n as 2 squared to the power of n, and then I can express it as 2 to the power of n squared. So I have 2 to the power of n squared minus 1. Now, how does that help us? Well, it helps us because we have a difference between two squares. So we can express the numerator as 2 to the power of n minus 1 over, and then the denominator we can express it as a difference of squares. When you have a squared term minus another squared term, and you know 1 is a squared number, then we have two brackets. One will have a positive sign in it between them, and the other one will have a negative sign. And then we write the square root of each of these terms in the bracket. So we have 2 to the power of n plus 1 and 2 to the power of n minus 1. And then you can see that 2 to the power of n minus 1s will cancel. It's like this is 2 to the power of n minus 1 times 1. So it's a common factor of the denominator and the numerator. So you're left with 1 over 2 to the power of n plus 1, which is the answer. So there's kind of like a disguised square, so one of the clues you should have seen is that 4 is a square number, which can be written as 2 squared, and then we can write this as 2 to the power of n squared. Okay, if we have 2 to the power of n, okay, if we square that, we get 2 to the power of 2n, which is the same as 4 to the power of n, okay, because 2 squared is the same as 4. So that's something that is a little trick that you need to look out for. And later on, when we get to disguised quadratics and quadratic equations involving these kind of situations, then it's something that you need to look out for. So I included this question for a reason, and the reason is because we have to be looking out for this kind of thing when we're solving exponential equations later on as well. So it's something that will help us to lay the foundation if you understand that. So the basis behind how to solve this is to understand the law of indices, that a to the power of m to the power of n is equal to the a to the power of m times n. And you can switch these two around. That's the same thing. So this and that will give you the same thing, a to the power of m times n. Okay, so that's what we've done here. We've realized that this is the same as this, and therefore we have a difference of squares, and then we can cancel out the common factor and we get our answer. I hope that was clear. Now, other questions, if I ever get to answer them from this particular paper, okay, which never know in the future, you'll find other questions from this paper in the playlist that will appear in this region over here. Other questions from the end of topic worksheet number 1 from my Cambridge Algebra Basics P1 end of topic worksheets. You can find other questions from that in the playlist that will appear over here. Other questions from the topic, I guess, of algebraic expressions, you can find that in this playlist over here. And you can subscribe to my channel by clicking on this link, and you'll see a card at the top that will appear which takes you to a video which explains how to use my channel to find what you're looking for quickly. Thank you for watching, and see you soon.